Okay, in this last video, I'm going to work the rest of the problems out. Number 18 wants us to find the formula for the inverse, and then it also wants to check whether the functions undo each other. So this identity says if you start with the original function, you plug an input into x into it to get the output f of x, and then the inverse function will send that output back, that y value, back to where it came from, back to x. The second one says if you start with the inverse function and you plug a y value in, you're going to get an x value out, and then the regular function, the original f, is going to take that x value back to the y value. Alright, I'm just going to find the formula, and I'll leave it to you to check that these two things work out. Okay, so to find the formula, we do the usual. We set y equal to f of x, or y equal to the formula defining f. So we set y equal x cubed plus 2. We're going to subtract 2 from each side, isolate the x term. There's only one of them in this case. Y minus 2 is equal to x cubed, and then take the cube root of both sides to solve for x. With a cube root, you don't get a plus or minus, or with an even exponent you do. With an odd exponent or an odd nth root, you just get one solution. So our inverse function, or our formula for our inverse, is this cube root of y minus 2. Or we could write that in terms of the variable x, which say f inverse of x. It would be the cube root of x minus 2. Okay, so if you plug them into those identities, they'll unwrap each other, the original function and the function f itself, function f inverse. All right, now let's take a look at number 19. Okay, so for this one, we're explicitly given the domain for the problem. We're told the function is x squared plus 5, but it's only for x bigger than or equal to 0. So our domain is from 0 to infinity. Now, to find the range, we'll look at it algebraically by looking at the definition. Y is equal to x squared plus 5. We know x squared, no matter what we do, when we square numbers, it's got to be bigger than or equal to 0. And therefore, this quantity on the right is bigger than or equal to 0 plus 5, which is 5. So it would say that y has to be bigger than or equal to 5. Okay, we can also look at this graphically. All right, so we know that the function x squared plus 5 shifts the original parabola up 5 units. We're only graphing that for x bigger than or equal to 0, so let's plot a few of the base points. Okay, starting at 5, then we draw our normal parabola. Okay, now looking at that, the lowest point on the graph of that function is at 5. Right, well, the lowest y value is 5. Okay, so we don't have a highest y value. It continues on forever, and this will tell us that the range, which is the output set, or the y values, is from 5 to infinity. Okay, same as saying y is bigger than or equal to 5. Now, the domain for the inverse function, okay, the inverse function sends the outputs back to the inputs, so the domain of the inverse is the same. It's 5 to infinity also. Okay, the range of the inverse function is the domain of the original. Okay, the range of the inverse for sending the outputs back to the inputs, they got to come back where they came from. So the range of the inverse is from 0 to infinity. The domain for the inverse is therefore 5 to infinity. Now, you want to find the formula for f inverse. We're going to write y equal to x squared plus 5, and then do the two moves to solve for x. In our case, we're going to subtract 5, take the square root. So we're going to get that x is equal to square root of y minus 5. Notice we don't get the plus and minus. We only get the positive solution because x is only valid for non-negative numbers. Okay, we're only allowed to plug non-negative x's in. So that's our formula for f inverse. F inverse of y is equal to the square root of y minus 5. Okay, I'm going to skip part f to verify that these functions undo each other. But to graph this, we're going to write the inverse function in terms of the variable x. So we're going to write f inverse of x is equal to the square root of x minus 5. Notice it's just a different letter. It still performs the same actions. Whether you write it with y or x, you're still taking the input, subtracting off 5, and then taking the square root. But with this, we know how to graph. The minus 5 on the inside tells us to shift the graph of the square root right 5 units. So we're going to start at 5 and then put a few of the points we know about down for perfect squares, and then we draw our usual square root graph. All right, so that's the graph of y equals f inverse of x. All right, now they're plotted both on the same axes here. Okay, moving to the last question from the 2.7 example handout. We've got this function g is defined by g of t equals the square root of t minus 2. Okay, in this case, we are going to answer these similar questions that we just did. We want to find the domain of g. This time we're not given it, so we have to explicitly say what it is. Look at the formula, we know we can't take the square root of a negative number, so we need whatever's inside to be bigger than or equal to 0. We need t minus 2 to be bigger than or equal to 0, which tells us that t is bigger than or equal to 2. So that's our domain. T is going to be bigger than or equal to 2. If you want to write that with interval notation, it's 2 to infinity. For the range, this one's a little bit more delicate. Okay, you just have to know that whenever you take the square root of a positive number or a non-negative number, it's going to be something non-negative. Or look at the graph of the function. Let's look at it graphically. Okay, so we know that that's a shift to the right 2 units of our base graph, our parent graph, square root of t. All right, so what we're going to do is to start out at t equals 2. So 2 on the horizontal axis. Plot a couple of points we know that are on the graph. Right, so we're going over to 3 because we plug 3 in, it's like the square root of 1. We know the square root of 1. Plug 6 in, it's like the square root of 4, and we know the square root of 4 is 2. So we draw our square root graph. All right, this is the graph of our original function. This is the graph of g of t. Looking at that, we can also see the lowest point on the y-axis, lowest y value, pardon me, is y equals 0. Okay. So that tells us what to do. Okay, that tells us that our domain, or sorry, our range of our function g is 0 to infinity, same as we found algebraically. Okay, so now we want to look at the domain of g inverse. Well, the domain of g inverse is the same as the range of g. We know that the range of g, we looked at it algebraically, looked at it graphically, is 0 to infinity. Domain of g inverse is the same. We're sending the outputs back to the inputs. The range is same as the domain of the original function, which was 2 to infinity. To find the formula for the inverse, we write down y is equal to the formula. Now we're going to solve for the t in this case by squaring both sides. That gives us that y squared is equal to t minus 2. Solve for t, and we end up getting t is equal to y squared plus 2. All right, and that's our formula for the inverse. We can leave it as g inverse of y is equal to y squared plus 2, or if we want to graph the function g inverse on the same axes as the original function g, we should write it in terms of the same variable, same input variable or independent variable. So we're going to write g inverse of t is equal to t squared plus 2. Okay, and then plotting that, we know what that graph looks like. T squared plus 2, taking your original parabola, shifting it up 2 units. So we're going to start at 2 now on the y-axis, plot a couple of points we know are on our graph, and then draw our basic shape of our parabola. It's just a half of a parabola in this case because we're only allowed to plug in numbers that are bigger than or equal to 0 into the inverse function. Okay, now one thing we can see about these two graphs, this is true for any function in its inverse, they're reflections over the line y equals x. Those two graphs are symmetric about the line y equals x.